Hi, my name is Kevin, and I'm going to walk you through on how to make an RR leg in Geogebra and use the function generator MechGenFG, either the Mathematica version or the iOS version. Before we get started, what you'll need is Geogebra and a function generator. I'll be dividing this into 3 different steps. The first step, we will model the movement of an RR leg in Geogebra. The second step would be to find the angles for the hip and knee joints. And the third step would be using the function generator itself. Let me just show you what all the steps look like first. So let me open up step 1. So quick edit, there should be a red triangle there instead, like he mentioned in class today. So I'll teach you guys how to do that later on in this video. Okay, so this is the RR leg. You can see here the trajectory, the crank, the coupler. So the figure on the right here is for you to adjust the points. So you can adjust the points here, 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 and these, wherever these points are, the dimensions, it's up to you. That means everyone's leg will be different, and that's the beauty of it. So there will be many different designs. So the left one is for movement and the right one is for adjustment. Okay, let me show you step 2. Okay, so after you finish tweaking the leg to get the foot trajectory that you like, you're going to put 5 points on the foot trajectory and then record the input angle, the hip angle, and the knee angle. I'll go over this later, but this is basically what it'll look like. And then finally, the last step is to use the function generator to create this. This is actually 2 function generator legs combined into one, and they're joined at the hip. You can see here there's 2 cranks here, and we use a parallelogram to drive the lower leg. Alright, so now let's go ahead and do step 1. Let's open up Geogebra. And usually what I like to do is to hide the grid, options, labeling, no new objects. And then another thing I like to do, sort by object type. Alright, so now let's show the axes again. Draw a parallel line to the x-axis. And let's choose these colors to be 1/8 gray. And let's hide the axis again. Okay. So this point will be a fixed pivot. So let's do a hollow circle and brown. And let's create the other fixed pivot. Let's just put it here. And then again, that color would be brown and hollow circle. Okay. So the next thing, you want to create a polygon from the first pivot. Let's draw a triangle. Any triangle would do, anywhere you want. Let's do a line segment down here. Now this is the parallelogram that we want to create. So let's do parallel line from this line segment to here, this line to here. And then let's create intersection point. Now in Geogebra, if you didn't change any of the colors, the intersection point will be black. Now let's hide these lines. The command for that is Ctrl-G. And then let's draw a segment here. Again, let's draw a polygon here. Anywhere you like. And now let's make the crank here. Let's put a circle using compass here. And then let's put the coupler curves here and another edit. So you just put a triangle here instead. And then you put your coupler. And this one's red. And there you go. This is your RR leg. This is the adjustment figure, as I said, the one that was on the right. I'm just gonna resize this a little bit so it looks a little bit better. It's not necessary, it's just, I just feel like it looks better. Okay, now let's color code this. Let's make the polygons violet. This will be cyan, and this one will be red. Coupler curves blue. Let's make this circle, is it gold? Yeah, gold. And then let's make all these points, except for the pivots, again, light gray. Let's draw a line segment here to here, and make that gray as well. And make this, the crank, green. Alright, now let's do the movement figure. Alright, let's use a compass, select the 2 pivots. Let's find intersection point. Alright, so now you see this is blue, so that means it's not intersecting anything. So I made a mistake. We want it to be black when it comes out. Yeah, so that's the intersection point. You also want to make sure that this point is on the line. Alright, before we go any further, let's save the file. I just named it S1. And then now let's create 2 sliders. Angle, let's do rotation. Another slider. This will be crank. And that's angle too. Alright, now let's do angle with given size. Select the right point first. And this would be rotation. Let's try to match this with the figure on the right, so it's easier to visualize. There. Now we can hide the circle and this point and the angle. Let's make these 2 the same size. And then hollow circle and brown. Let's draw a line segment, and that would be light gray. Now let's make this crank. So use a compass, circle here, intersection point here, and then let's do angle with given size. These 2 points, and this one would be crank. Now let's hide the circle, the angle, and this point. And this would be the crank, so let's make a segment, and let's make this green. We can color code the rest later. Let's just do this for now. And now let's create this triangle. Alright, let's use a compass. From this point to this point, let's put it here, and from the fixed pivot to this point, let's put it here. Get the intersection, hide the circles again. Let's get this point here. So compass, fixed pivot to this point, and then this point to this point, and the intersection, hide circles, and let's draw the triangle. There. Let's save our work. File, save. And let's see. Yep, looks fine. Let's put a coupler here. There we go. Alright, so now let's make the rest. Let's use a compass. And then what you do is use a compass, measure this thing here, here, and here. Find that intersection. Let me just hide these circles. And then you try and get this point. So compass again, here to here. And that intersection will complete the red triangle. So now you just use the polygon, make this red, it's gray, and continue. And then same thing, compass, this point, this point, this point, this point, and the intersection. Let's draw a segment here. Let's hide these lines. And then let's draw a segment from here to here. And just hide these circles. So later on the polygon goes down here from these 2 points. Now let's draw the last portion of our leg. So compass from this point to this point. Let's put it here, and this point to this point. And that intersection will complete our polygon. There. Now let's hide these lines, circles. And then let's create the same thing here from this point to this point, this circle. And it should work. Alright, so now you want to see the foot trajectory. So you go to locus, select this point, and click crank. Now let's color code this so it matches the one on the right. Alright, just make these the same. Cyan, red. I'm gonna select all these points except for the pivots and make it like gray, make sure they're the same size. A couple of curves are blue. Make this circle gold. Alright, let's make this trajectory orange, this point orange. Let's make this a little bit smaller. Alright, let's now create a parallel line here. And again, this will be light gray. So this is to see if your foot trajectory is flat. So now you have a foot trajectory, you have the adjustment figure, and what you basically do is adjust these points, all these points, and the rotation, and just find a design that you like. And there you go. This is basically step 1, complete. Alright, so after you have tinkered with your leg and found a design that you like, we're going to go ahead and move on to step 2. So in this step, what we're going to do is measure the hip angle with respect to the x-axis and the knee angle with respect to the x-axis. Alright, let's move this over here. And then let's draw a parallel line to the x-axis through the knee joint. Again, let's make that gray. Okay. To measure the angles, let's create a point here and here. What we're measuring is this segment and this segment here. Let's move the crank a little bit and use angle. So you select this point, and this point for your hip angle. and this point, and this point. So this would be your hip angle, and this would be your knee angle. Now let's label the hip angle. So let's do object properties and caption hip angle, and let's do caption and value, and let's make this red. And here, same thing, but knee angle. So knee angle. And again, let's do caption and value. And let's make this cyan. Now let's do the input angle. Okay, so let's put a point here and intersection again, and then let's do angle, this point to this point to this point, and that is your input angle. Now let's label that as well. So object properties, input angle, caption and value, and let's make it opaque. Let's hide these points, and there you go. Input angle, hip angle, and knee angle. So the next thing you're going to do is choose 5 points on your trajectory, any 5 points. The way I do it is actually not directly on the trajectory itself, because there is a bug in Geogebra where if you put points on the trajectory, open the file after you saved it, it messes up the locations and it just goes all the way to the bottom again. So let's zoom in. To zoom in faster, you hold Alt and use your scroll wheel, and then let's choose a point here, 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 and here. You can choose anywhere you like, but I just choose these points. Just make sure these points are close to the trajectory itself, but not actually on the line. So like just relatively close. So now what you're going to do is create a spreadsheet. So view and spreadsheet. Let's make this column green, this one red, and this one cyan. You don't have to color this, I just find it easier to keep track of things. So let's make this black. And this one black too. Because these are, this will be your input angle, this will be your hip angle, your knee angle, and you'll put the 5 angles that corresponds to each point here. And then what you're going to do is right click input angle, record to spreadsheet, hip angle, record to spreadsheet, and knee angle, record to spreadsheet. And then let's rename this quotations input angle. This one quotations hip angle, and then this one knee angle. And let's close this. Now we move the crank all the angles will be recorded on the spreadsheet. So now we're going to find the angles that corresponds to each of these points. So let's say the first one is this point. So it'll be this entry. Let's put this here. And then let's go to the second point. It'll be this here. Let's go to the third point. That'll be this row here. And then you just do that for the last 2 points. So you should end up with something like this. The 5 different angles corresponding to each point here. And that's it for step 2. So for the last step, what you're going to do is use these angles here and put it into the function generator, either the iOS app or the Mathematica version. So for the app and the Mathematica version, you can only input 5 input angles and 5 output angles. So what you're going to do is basically do the function generator 2 times, and the input angles will stay the same. The only thing that will be different is the output angles. So the output angles would be the hip angle and the knee angle. So you run the program 2 times. The first time you run it with the input angle and the hip angle. The second time would be the input angle and the knee angle. So that means you will have 2 legs. And then what step 3 is basically putting these 2 legs together. And I know Professor McCarthy has a tutorial on how to use the app, but it's basically the same as Mathematica 2. So I'm just going to show you on my computer the Mathematica version. So let's open up the notebook. If you need this file, just email me or hit me up on Discord and I'll send it to you. Alright, so here is the function generator. And you'll be inputting angles here. Now before you do that, you can change the tolerance of the angles. So you could do like a plus or minus 5 degrees or whatever you want. It's up to you. You can also set the number of iterations. I put 100. If it's too slow, you can do 10. Alright, so before you do anything or input anything, you want to hit Control A. So that selects the whole document, and then press Shift Enter. So that will run the code. And then go all the way down here. Here. And then you want to click Reset. So now you pull up your Geogebra. And then you input these angles, the input angle here. So I already did it. So it's 0, 88, 162, 198, 270. And then so we're running this the first time. So this will be your hip angle first. So you do the output here, 244, 284, and so on. So what OX and OY is basically this point up here. It's the green one, the input crank location. And then CXCY would be the output crank location, so here. Now it will be different depending on where you put it. I mean, you could put it anywhere. Let's say -5. And then let's do, I don't know, 9. I recommend just leaving point C alone. So just leave it at 0, 0. So when you do the Geogebra file, it'll be easier to integrate. Alright, I'm just gonna make it -2, 2, because I think it looks good. And then what you'll do is click Compute Linkages. It'll run for a while, depending on how many other iterations you did. So just let it run, and then when it's finished running, this black bar here will disappear. So just wait and sit back. All right, now it's done running. Let's see, and there's many solutions. It depends on the iterations and how many iterations you inputted. So you can choose any from this list. Choose one that you like, and then let's say you like this one. So what you do is right click, save graphic as, and then save it anywhere that you like. Save it as a PNG file, and then name it whatever you want. Now for the iOS app, it's basically the same thing. You just input your angles and your output angles, and then the tolerances. I think there is a auto tolerance option. It's up to you if you want to use that. And then you click compute linkages, view solutions, same thing, you choose the one you like, and then you email it to yourself. And what you'll get is something very similar to Mathematica here. You'll get something like this. Again, save this on your desktop, and then we'll refer back to it later. And you basically want to do this function generator 2 times. So the first time is what I walked you through. We did the hip angle. You're going to do the second time the same thing, but now for the knee angle. Just remember your input's the same, just your output's different. Again, the important thing to note is make sure your CX CY is the same when you're running the code 2 times. So 1 time for the knee and 1 time for the hip. What you can do is choose different OX and OYs for the 2 different function generated legs, 1 for the hip, 1 for the knee. But I'm just going to make it the same here. And again, it's up to you if you want to have the cranks separated. I can show you what that looks like compared to when the cranks are together. So let me show you first what it'll look like if the cranks are together. So meaning the OX and OY stay the same. So if you remember this is what I showed you. So you can see here the crank meets at 1 point. So when you're building this where the cranks meet at 1 point, you might need a crankshaft. And then let me show you what it looks like if your OX and OY are different. So your cranks are separated. What you'll get is something like this. So you can see here the 2 cranks are separated, and then they spin at the same rate. You can do this too if you want, but I'm just going to do the one where the cranks meet at 1 point. Now when you're building this is just like the animation Professor McCarthy showed you guys at the beginning of the quarter, where we use 3 gears, 1 attached to the motor and 1 attached to this crank, 1 attached to this crank to drive the leg. So basically what you're doing is attaching the motor to 2 gears, so they drive these 2 cranks in sync. Alright, now let's go back. So what you'll end up with are 2 figures. 1 function generator figure for the hip and 1 for the knee. On the iOS app, it'll look something like this. And this one's for the hip, this one's for the knee, and your design will be different. And then if you're using Mathematica, just ignore one of mine here. You'll have 2 as well, hip and knee. Alright, so now let's open up a brand new Geogebra file. Again, what I like to do, hide the graphs, the options, labeling, no new objects. Alright, now let's grab your design screenshots. 1 for the hip, 1 for the knee. Now the important thing here is the points O, A, B, and C. Same thing for the knee, O, A, B, and C. If you're using Mathematica, it's the same thing. Point O, point A, point B, point C. O, A, B, and C. So what I like to do is actually drag the design screenshots into the Geogebra window. That way you can refer back to the figures, the points in Geogebra without leaving the Geogebra window. But you can just pull up the screenshot. I just don't want to go back and forth, I feel like this way it's a little bit easier. Now if you use the app, it's the same thing. Just drag it in and you can do it inside Geogebra as well. Now for simplicity, I'm just going to use the Mathematica version, but it's the same thing. We'll still be looking at these 4 points. So let me remove this points. Just make sure you know which figure is which one is the knee, which one's the hip. So I know this one is my knee. I'm just going to put it down here. My knee, and this one is my hip. I'm just going to label it so I don't get it mixed up. So this one is hip, and this one is my knee. I'm just going to make this bigger. Whoops. Okay, so the next thing is to know where these points actually are. So I'm gonna label this figure. It will be the same for the bottom figure too, and also the same for the iOS version. Okay, so this point here, this would be point C. I'm sorry, O. This point here is A. This point here is P. And this point here is C. And this will be the same for the bottom one as well. So O here, A. Here, let me just show you. So O, A, B, and C. AB is the coupler, OA is the crank, CB is the follower. And this black line, these black lines, are your corresponding input and output angles. And this is the same for the iOS version. So here, this will be point O, A, B, and C. All right. So what we're doing right now is exactly the same as step 1. So we're going to create a adjustment figure based on this figure here. And then there's going to be 2, one for the hip and one for the knee. We're going to overlap those 2 figures together and then use that figure to finally create a movable figure. So it's basically figures everywhere. All right, so now let's show the axes. Let's just move these somewhere where we can see them. All right, and I'm gonna do object type. Let's do the hip figure first, and let's create point C. So here, point C will be 0, 0. So let's input it down here. We have 0, 0. Yep. And then since this point's a fixed pivot, let's do half circle and brown. Now let's do the other point, the other fixed pivot, point O. That'll be -2, 2. So -2, 2. And fixed pivot, so open circle and brown. Just gonna move this out of the way. You right click to select all. And then the next point, let's do point A. Point A is -272. It'll be different for yours, so 2.72. It's right here. So this is the crank. And in our figure here, it's a polygon. But we know this line here are the corresponding angles. So this will be input angle 1, 2, 3, 4, and 5. It'll be the same for the app as well, I believe. Yeah. Angle 1, input angle 2, 3, 4, 5. So knowing that information, we know the first angle is 0. So I'm going to draw a parallel line, a line parallel to the x-axis at point O. So far you have the crank. Let's just put a segment here. But we don't have the input angle here. So to get that, we look at here. Now if you're using Mathematica, the input angles are right here. And whatever tolerance you use, the input angles up here is what the program used. Now if you're using the app version, you'll want to use the randomized task positions here. This is because these are your original input angles, but after the auto tolerance or whatever tolerance you used, it'll use these angles instead. So when you have auto tolerance on, and if you have tolerance that's not set to 0, just use these randomized task positions. Now the good thing about Mathematica is the input angles here, it already takes in the tolerance into account. So you don't need to worry about what your input angles are and what the program used. This is exactly what the angles are. So this point here will determine your input angle. So mine's 0, so it's pretty easy. So I know it'll be parallel to the x-axis somewhere here. But now if you have a really weird input angle because of the tolerances, let's say it's like 2 degrees, it'll be slightly up there. So the way you do that is first, let's create a point on the line that's parallel to the x-axis. And then let's use a compass, not a compass, angle with given size. Select the right point first, then the pivot. And then, yeah, let's say your angle is 2 degrees. So here. And now let's draw a ray from the fixed pivot to your input angle. So let's say yours is 2 degrees. And then what you want to do is put another point there. And now let's hide all that. And this parallel line as well. And the angle. Now let's draw a polygon. And that would be your input crank at a 2 degree angle And wherever this point is doesn't matter, because what matters is the input angle, and it's constant no matter where you put it. Now let's color code this first, because it gets confusing once you start overlapping things. Alright, so let's delete this segment we made earlier. And let's make this triangle green. And then these points would be light gray again. And let's draw a line segment from here to show our input angle. Actually, let's make this black. And again, this is adjustable because the angle does not change. I'm going to just do object type. And point B is this for me. So negative 1.18. Alright, and it should be, yes, right here. I'm just going to change this triangle here because my input angle is not actually 2 degrees. My input angle is 0 degrees, but yours will be different. So I'm just going to change this here. So I'm going to change it to my own input angle. Let's just delete that. Now, if you actually have 0 degrees, it's pretty easy. Just put a point here. This is the line parallel to the x-axis, and then just draw your polygon here. That's it. If yours is actually 0 degrees. And I'm going to make this the correct color. Alright. Now for our second polygon, we need to know the first output angle, or the output angle that corresponds to whatever input angle you have. So for mine, when my input is at 0 degrees, the output is at 245 degrees, which is this black line here. So I'm going to make that right here. Again, if you're using the app, just make sure you use the correct randomized task positions. So let's say your input angle is negative 0.27. Your first output angle would be 242.36. So now I'm going to draw a parallel line, x-axis at the pivot here. Draw a point here. Whoops. Draw a point here. And do angle with given size. And it was 245 for my figure. Right there. And then we're going to hide this point, this line, the angle. Let's draw a ray from the pivot to the angle that you measured, or I mean the angle you outputted, your output angle. And then let's put a point here. Whoops. A point here. Now this point is draggable and this is not, because this was defined by the point that was here. So that's why you create another point on this line. Same as this. Alright, so now I'm gonna hide this line, this point, put it up here, and that is our other polygon. So for the hip triangle, let's color this red. And then for the points again, let's make it gray. And this one, let's do a segment here to show our output angle. And you can see here, this is fully draggable. Now before we drag anything here, let's make sure we fix these points, because these points cannot move. So let's select all these points. So the pivot here, the point here, another pivot here, and this point here. Right click it, object properties, and fix object. fixed, 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 fixed. Okay. So that just prevents us from accidentally dragging these points that are not meant to be moved. Only these can be moved. Alright, so now we can see AB is our coupler. Let's make that coupler here. So A and B. And this will be blue. Let's save this document. I'm just going to call it S3. And this is our first function generated hip leg. So now what we're going to do is overlap the knee onto here. So that's why it's very important to color code this, or else it's going to be really confusing. So we're going to do the exact same thing. So I'm just going to speed through it here. Feel free to fast forward. It's going to be the exact same thing. All right, so point O, point A, point B, point C. So my point O and point C would be the same, because that's how we defined it earlier when we were inputting the angles. Yeah. So all we need to know is point A and B, and these points that define the angles. All right, so I'm just going to speed through here. Feel free to skip it and see the end result. So let's do point A. Point A is -3.24, 2.42. Okay. Point B. Our input angle is 0 again, so I'm going to do the trick. This green to gray. This one black actually. Line segment here to show the input angle, and that's our input crank. And we know point C is the same, so all we need to do is find point B and then the point here that defines the output angle. So point B here is -0.48, 3.44. That's our point B. Now my triangle here is a bit funky, so yours will probably look way better than this. This is really bad, but the results will be the same. So if yours look like this, it doesn't really matter, because the end result will still be beautiful. So now we need to find our output angle that corresponds with input angle. So our input angle was 0. That means our corresponding output angle is the first one. That's 284 for mine. I'm gonna hide this line here. I'm going to do a parallel line, or you don't need to do this. You can actually just put a point here. It's the same thing. What was it? 284. 284. And that is our first output angle for the knee. So I'm gonna draw a ray here to here. Let's put a point here. I'm gonna hide this point, this point, this point, the angle. Let's draw a polygon. And this should be fully movable. Whoops, whoa. Alright. This should be fully movable. because this, let me put it here. Segment from this line to this line. So this defines our output angle for the hip, for the knee. This one is for the hip. And since the input angles are the same, they are on the same line. Let's make this cyan. The points here and here, let's make that gray. And then before I forget, let's fix these points so we don't accidentally move them. Object properties, fix. Yep, that's fixed and fixed. All right. So the only thing that could move are the points that define our input angles and output angles, because these don't change the angles at all. Now, one last thing is to create this A and B. So that would be here. And let's make that blue. So the last thing we're going to create is actually the movable figure of this adjustment figure here. And then before we do that, feel free to get up, take a break, because this last part is basically the finale. All right, make sure you save your work, or else all is lost. All right, so for the next part, it's going to be a little bit confusing because everyone's figure is different. But what we're basically doing is what we did in step 1. So remember, we created a adjustment figure. So what we're creating is basically this thing here on the left. So we have the right one. It's just a little bit more complicated. And we're just going to create the left one here. Yeah, so this was the right one. Okay. So now what's going to happen is we're going to create these legs that overlap each other. So the only constant we have is these two fixed pivots. So let's create that first. So again, let's create two sliders. Angle, rotation. And another one, angle crank. Let's draw a parallel line to the x-axis. So we have a reference point. Let's just put it here. And that would be this fixed pivot here. So again, hollow circle and brown. Now, in order for the rotation to work, we're going to make this line rotate with this slider. So the way we do that is let's just create a point, and then let's do angle given size, rotation. And then you rotate this, you see that line, that point I mean. Then you do a line, and now you hide this line, put 0, hide this point, and now you want to define this point. So use a compass between two fixed pivots here, and then what you want to do is put an intersection point here, and you want to measure the angle from here, from 0 degrees all the way over to the other fixed pivot. So let's put a point here, angle, let's measure this angle here, and then 135. All right, so now use angle given size, click here, fixed pivot, 135, and that would be your other fixed pivot. So let's make that point brown and hollow circle, and make sure the size is the middle one. Now we can hide this, this, and this. Now we create another parallel line to this line. Remember, this line rotates, so the crank will rotate with it too. All right, so now it's up to you if you want to create your hip first or your knee. I'm going to create my hip first, and I'm going to bring this up here so it's easier to see. So look at my diagram here. My hip one is the one with this kind of triangle, so it's this one. I'm gonna just make this something else first because I can't really see. So we know this is the input crank, and this is the other one. This is the knee, and this is the hip. So let's create the input crank. So let's go compass from the fixed pivot to the hip input angle point there. Let's make this a little bit smaller. Intersection point here, angle with given size, and this would be the crank. Alright, so let's hide this point, hide this point, hide the angle here. Let's create a segment. And then we're trying to find this point here. This one. So to do that, create a compass. Right here, and put another compass from here to here, and that intersection point. Let's hide that, let's hide this, let's draw a polygon. I'm going to delete that line there. I'm going to create a line on top of it actually, there. And let's make this dark green for now. We'll change it later. And it works. And let's make this gray. Same size. Alright, so the next thing, remember we're still doing the hip. So the hip is this, this, and this. So I'm going to create this point here. Alright, so compass, fixed pivot to this point. Let's put it here, and then the coupler, let's put that there. And the intersection point would be this point. And let's draw a line segment. And let's hide all these circles. This one will be blue. And light gray, medium. The next step would be to find this point, the last point of this polygon. So compass again. Let's do here to here, and here to here. And then in the intersection point would be there. Then let's draw a polygon. Let's make that red. Hide the circles, make the dot gray and medium. And let's see. That's perfect. And you can adjust this. Alright, now we're going to move on to the knee. I'm going to put this down here. Yeah, put down here. And again, same thing. So I'm going to speed through it a little bit. Again, make sure you save your document. All right, so again, we are going to create this triangle here. So we need to create this input angle. So what we're going to do, compass, input angle, find the intersection point and angle given size. And this will be crank. Where's our sliders here? Whoop. Let's hide the circle, the point here, and the angle. Now I'm going to drag this smaller so we can see the other point. Make this black. Medium size. And now we're going to do the same thing to find this point. This point is the point for the knee. And this one here is the hip. All right. Compass from here to here. And from the knee input angle point to here. Okay. And then let me just move this out of the way. The intersection point here. And that is your polygon. So I'm gonna hide this point here, here, draw a polygon here. And I'm gonna make this light green. Let's draw a segment from here to here. Okay. I'm going to just change the color of this to light gray and size medium. Just make it so it matches. Now a quick way to check if you're done it right is to just see if it's the same. Yeah, it's the same. So you did it right. And then next we're going to make this blue triangle here, cyan. So what we need to do is find our output angle that corresponds to the input angle. So our output angle 1 is 284. But first let's find the point, the coupler points. So let's do compass from the fixed pivot to here and from here to here. Now these points are all the knee points, so they're not the hip. It gets confusing if you have a bad triangle like me here, but if yours was more separated, it should be a lot easier to differentiate. And let's put this circle here. Let me just do that again. So these 2 points here, and the intersection point, well, this point is this point. So I'm gonna hide the circles here. Oh. Hide. And then what we're going to do is get this line, the output angle line. So this is 284. All right, so before that, let's just make this coupler first. This coupler is basically this line. So let's make this blue. And this one will be light gray, medium size. So now let's find this point here. So let's use a compass, fix pivot to this point, and then up here to here, and that intersection. Oh yeah, so sometimes you gotta zoom in. And if you can't really tell, you can use intersect between these two circles. And it looks like, yep, it's this point here. So let's hide this point, let's hide the circles. Let's make this gray. And then there is our polygon. And now you are 90% finished. So let's hide this line here. We don't need these lines. Let's make this cyan. Let's double check. Let's draw a segment for the output angles so we can know where it is. Let's check if it works. And everything looks like it should work. So the most amazing thing here is the foot trajectory that this draws out will be, well, it should be identical to the one you made in step 1. Now to quickly check before we make the parallelograms and everything, this is the, alright, so this is the knee and this is the hip. So if you put the knee below the hip, the line that it draws out should be the foot trajectory. So before we do all that, let's just check if it actually is. Let's do a compass from here to here. Let's do a parallel line. Parallel line to the, I always get mixed up, to the knee. Down here. Intersection point here. And to check it, let's just move this somewhere out of the way. So to check, you basically select locus, this point, and then crank. And it should look relatively similar. Now if it isn't, then all you gotta do is just adjust these points. Let's turn on the animation first. And that looks exactly like my version of step 1. Yours will be different, but that's basically a way to check if you did this correctly. Now, yours probably look way better than mine, because mine is pretty funky up here. Now that doesn't really matter, like I said, because the output, the final result will still be really good. Even if your triangles here are really weird. Alright, so now let's just delete this, because this is just to check. And let's move this figure all the way down here out of the way. Now you can change the input angle here, these lines, to be the same if you want, or different. It's up to you. These won't change the trajectory as long as you don't go past the pivot point. So I'm gonna just make it the same. Now if your input angles are different, it's up to you if you want to make them the same, longer, shorter. That doesn't matter as long as it doesn't go over like here, because that will change the thing. Now these 2 points matter. So once you have the foot trajectory displayed, you can change these. dimensions here. Okay, so what we're going to do now is the final portion. Let's create a perpendicular line to the knee output angle line. So here to the pivot, and here to the line, to the point there. Let's create any 4 points here. This is just to create an area where you can have your polygon. You'll see that in a second. So now let's use your polygon tool, select these 4 points, and choose point on object. This is important. There. And let's create another polygon here. And we can hide this one here, this one here, this one here, and this one here, and this line. So now we're going to create the parallelogram. So parallel line to the hip output angle line. Let's put that point up here, and the parallel line to this line down here. And there is a intersection here. And let's just hide this line and this line. Let's draw a segment here. And then you're going to use your compass. Select the fixed pivot at the end of the output angle line of the knee. And then you're going to put it at the end of the output angle line of the hip. And now you create a parallel line to this line. This is the output angle line of the knee. And put it here. And put a point here. And you are almost done. Let's put a polygon here. And that's it. Let's hide this line. Let's hide this cyan triangle and this line. And this line here. And let's animate this. Oh, make sure you do object properties and slider speed increasing, so it doesn't bounce back and forth. And there you go. That's all there is to it. And make sure that the parallelogram does not collapse. So what I mean by collapse is, so there, that collapsed. So make sure there's still some space at its extremes. Just play with it. Play with this point here. You can change the shape. And then one last thing is to show the foot trajectory. So let's select this point and locus. So after you select locus, select this point again and crank. And you can see here the foot trajectory may not be what you have designed in step 1. So what you can do is actually animate this and then just change these 2 points so it matches the trajectory. So let's do that. So that matches my design, and yours will be different. Again, just play with these 2 points until you find the trajectory that's correct. And then also just make sure that the parallelogram does not collapse. Okay, so the final step would be for you to record. So before we do that, let's just move. Actually, I'm gonna make this longer a little bit. And this maybe a tiny bit smaller. Yeah, okay. So I'm gonna move this down here out of the way. And then I'm gonna hide the axes. I'm gonna draw, actually show the axes first. Draw a parallel line to the x-axis. Put it here. Again, make this gray. I'll make it a little bit darker. And then put a line here. Let's make this orange. This point orange as well. And these 2 points, gray and medium. And the upper triangle, purple or violet. And also the lower triangle as well. Now this segment will be cyan. This segment, I'm gonna delete this segment. Oops. Select other. 7 and 2. Delete. This one's red. And these two should be the same color. I want to make these points a tiny bit smaller. Select other. And there you go. So all you gotta do now is just record this and submit it. I hope this tutorial wasn't too confusing. We look forward to all of your awesome leg designs. And stay safe and have a great rest of your week.